Today is December 29th, 2022. This is my 175th episode for C++17 2023 CUDA SQL OpenGL OpenCL TBB Vulkan. This is 5th episode for Vector Calculus Operator Overloading 1 Class vctr3d Design. Please understand, I cannot explain everything. If you have C++ library extension, this source code, you have to refer to this source code. For example, if you unzip it, in this folder include CPG, you have to reference to the source code by yourself because I cannot explain everything in this source file. I assume you have watched my previous video, episode 174, Vector Calculus 4. Please double-click this link. From episode 174, Vector Calculus 4, show more, download current video source code. Click this link. Show in folder, unzip it. Rename 175. Copy, paste it in your working directory. Now open up Visual Studio Code. From folder 175, open up CPG vector HBP test.cpp. Ctrl B. I will arrange side by side like this. In the CPG vector.hpp, we created hidden all non-callables are of same floating point C. This concept in our previous episode, episode 174. Also, vctr3d puncture valid element C. This concept implements two rules. Rule number 1 is implemented through this concept. At least one should be callable C. Rule number 2 is implemented. All non-callables are of same floating point C. I will enable it. If you scroll down, you can delete this. Now, see the squiggles. From here, this is valid. This is valid. This fails because this is integral type. See the squiggle here. So I will disable it. This is valid because this is floating point float. Floating point float. This fails because this is double. This is float. Different floating point. So I will disable it. Let's double check. It is valid because this is double, double. This fails because this is double, this is float. So we can fix like this. Then the squiggle goes away. Now we can try our code. I will open CD 175 vctr3d clang std c++20 test.cpp ltbb 12 or c.exe. Hit enter. CLSC. Everything works. Now I will disable it. Instead, I will enable test concept and constraint. This function is defined here. We want to display some result. In this function, I want to define std cout a A, CPG, and there. Copy, paste. This is C, C. Then this is E, D, D, D. This is F, F, F. The function name is I will go very slow. So I will enable this, then disable this. Of course, we have to define output stream operator. This is vctr3d element type. Here I will define using like this. Using vctr3d, I will call it scalar t. I will implement like this. With this, we can define operator. I will define operator here. Template, type name, character type, std, floating point element type, std, basic, all stream. We use this character type, value reference, operator. I will copy this and paste it here. OS. I will try to use this like this. Element type, constant value reference B. Now OS, please understand I use CPG character str angle bracket colon then B M X, copy, paste. This is comma, this is Y, copy, paste. This is G, then copy this, paste it here. Now closing angle bracket, then return OS. With this, let's try to build CLSC. Now we can display vectors in pretty format. So we are displaying vector A, vector A, vector C, vector C, vector F, vector F. You probably wonder why I use this. The reason is that we can use WC out. Okay, we can also use WC out, WC out, WC out, wide character string. You don't need L. Okay, I haven't used L. It automatically converts. If you try it, CLSC. So you can use wide character string without using L. Without using L, you can use both W string, just C out, and WC out. You can use any operator. To such implementation, I used this macro. Now we want to evaluate these functions like this. Scroll down. Here we create member. Please understand fx, fy, fz can be lambda or value such as double or float. Auto evaluate x. LCD floating point or t. Constant no except. Return evaluate f x t. Copy paste. This should be evaluate y f y. This should be evaluate g f g. Template LCD floating point element type. We use this vctr3d scalar here as a return type. Operator element type t. We need constant no except. Return. We are returning vector3d scalar t. This is equivalent to vector3d element type. We call evaluate x t. Copy paste. This should be evaluate y evaluate g. So we are forming this vector. Okay, we are returning an instance of vector3d element type. Don't forget, we need constant no except. I cannot explain how I implemented evaluate. Right click, go to definition. Here you can find evaluate. You have to refer this source code. Now here we need operator using namespace cpg operator constants because we need file which is defined in this namespace. Now here you can say auto angle phi over I will use 6. Okay, this is radian angle. Auto degree CNA radian 2 degree angle. I say radian angle. This is radian angle. Now here LCD Cout A, we display degree. Then we can evaluate A. This A has 3 lambdas, each a function of t. I will put like this. Then CPG and that. Copy this, paste it here. This is B. This is not T. This is radian angle. Copy, paste. This is E. This is E. So to evaluate vector E, we call this operator. This operator is defined here. It returns vector 3d scalar t. Vector 3d scalar t is this type. We use evaluate x, evaluate y, evaluate z by passing t. In this member function, we evaluate fx. Fx is this value. We evaluate fy, fy this value, fz this value. With this, we can use any compiler. I will use Clang, then I will test with the Microsoft compiler too. CLSC. Sorry, this is test concept and constraints. Test concept and constraints. I will disable it, enable it. We can try again. CLSC. So, in case of A, this is A, degree is 30 degree. If we evaluate this lambda, this is the result. Okay, in this case 2.5, B 2.5 is 2.5, and fy, function y, function z are evaluated correctly. In this case, E 2.5, 4.5, 2.5, 4.5. Then this lambda is evaluated like this. We will try CL, EHSC, SDD, C++ training. It should be lowercase. Test.cpp, fe, m.exe, hit enter. CLSM, Microsoft compiler, also works perfectly. In my next episode, we will learn how to differentiate vector A. Vector A's elements are function. We will learn how to differentiate each member. If we differentiate vector A, then we have velocity. We will learn how to differentiate each element of vector.